Hello everyone, I am Kemalettin. Today, with my group mates Rafik and Yusuf, we are going to talk about data link layer, which is second layer of OSI model. Let's start with the main purpose of layer 2. First of all, data link layer is responsible for communications between end devices. It allows upper layer protocols to access the physical layer media and encapsulates layer 3, in other words, network layer, packets into layer 2 frames. So, we say that layer 2 typically deals with frames and those frames allow for media access control. In this regard, I would like to emphasize that in data link layer, we are dealing with physical addresses. In other words, destination and source MAC addresses of network devices. Moreover, data link layer performs error detection to figure out if a frame is legitimate or if it has errors and thus reject them. Briefly speaking, functions of data link layer are multiplexing data streams, data frame detection, medium access, and error control. In addition, data link layer consists of two sublayers, logical link control and media access control layers. So, MAC address sublayer or media access control layer allows access to the physical media. Also, the MAC sublayer takes part in the process of data encapsulation. LSS sublayer, logical link control sublayer, ensures communication with upper layer content. The LSS sublayer communicates between the networking software at the upper layers and the device hardware at the lower layers. So, that's all from my part. Now I am giving the floor to my group mate Rafik.
So now let's talk about topologies. Topologies come in two flavors, physical or logical. The physical will show all of the connections, the interconnections, and then the things type of nature. Logical is going to identify things like the virtual connections, VLANs, IP addresses, the things of that nature. So that talks about how the wires and the functions are laid out. So now that we understand the topology and we can talk about communications flow on a medium. Communication flows one of two ways, half duplex or full duplex. Half duplex basically is one of the ways can communicate at a time. Full duplex you can both send and receive simultaneously. This is often called a shared medium. So now that we talked about typical topologies, we talked about how things communicate, what happens on when we want to send a message at the same time, what controls that. Those are called access control methods. And that's one of the two ways. If we are talking connections based access, that means it's going to be either half duplex or a full duplex communication. We have two different systems for communication: carrier sensing, multiple access with collision detection, CSMICD. This is typically used in legacy orders, switched hubs, and alike. If we are talking wireless carriers, sense multiple access with collision avoidance CSMICA, and that's used on wireless networks. If we are talking older technology, we have what's called the controller access, and essentially it's a talking stick or a talking token. So what is this in practice like? So what about CSMICD? Like what is that in functionality? Essentially, what is this does? It does lays the groundworks for communication on a shared connection like a star. If things are communicating and it detects another signal communicating, both devices will stop sending data. CSMICD, while it's legacy, it basically allows us to send and receive data. If two devices are communicating at the same time, that's called a collision. So that collision detection is when it sees two things communicating at the same time. It will wait and retry again. If it tries retrying again and it also detects someone on the wire, it will wait again, and it will do this as long as necessary until it can retransmit the data that CSMICD. If we are talking wireless, it will be CSMICA collision avoidance. Basically, half duplex as much as it can, and it will use a collision avoidance process to govern when the device can transmit. If it detects multiple devices, it will send it when an appropriate time is presented. So that's all. Thank you.
Thank you, Rafik. Hello, I am Yusuf Kurbanov, and I would like to talk about the data link frame. So the data that we get is encapsulated by a data link layer with a header and a trailer to form a frame. So sequential, we can state that data link frame is made of 3 parts: header, data, and the trailer. In general, frames will have these fields. The header is a start portion that consists of the frame start, addressing, type, and the control. The type will identify layer 3 protocols. Typically, it will be an IP packet. And the control will be the overall flow control. And coming to the trailer, it will consist of the error detection portion and the frame stop. So now I want to give example how data link layer works. Here we have source and destination, and we want to send data between our device and the web server. Also, we have NIC MAC address that the frame is going to use. So the router one will take it and will strip off the frame layer 2 information and will review the layer 3 information. And then it will replace it with the address that's going to the router 2. And the router 2 will do the same process. It will receive the data frame, will strip off the layer 2 information, and will review the layer 3 packet information, then replace it with the new frame. So what we can conclude here, what we can learn here, each, let's say, hop will remove layer 2 frame and will replace it with their own data frame. So now I would like to give brief information about the data link frames. So as my friend Kemalettin mentioned, MAC addresses. MAC is about how packets are placed on media. And at this point, Ethernet comes to work. It uses media access control, I mean MAC address. That's the 48-bit address written in the hexadecimal format. And Ethernet is responsible for Ethernet addressing, commonly referred to MAC or hardware addressing, and is responsible for framing packets received from the network layer. And another type of the frame is wireless. It's point-to-point protocol, it's high-level data link control, HDLC, and the frame relay. And all data link frames have one common side, that they can perform media access control for specified logical topologies. But the Ethernet and the wireless are the most used frames. So as a group, we have tried to give information about the data link layer, its protocols, how it works, and so on. Hope we were able to teach you something about this topic. Thanks for your listening. Thanks for your attention.